Hello and welcome to GOTO Amsterdam 2022 Unscripted interview. And today I have Eleanor Saitta, and I'm looking very much forward to this interview.
Thank you, it's nice to be here.
It's great to have you here. So I was listening to your talk about security and what can you do in an organization. And you had a lot of tremendously very good advice. You have like small things and you had big things. And I really liked that you could take away what you needed for your organization. I thought that was very helpful.
I mean, I never know kind of who's in the room, so
Exactly.
I try to give a bit of range. Everybody gets something.
Definitely, yeah, definitely. And I think it really worked, at least for me. So one of the things that I thought about a lot was that thing about immutable and ephemeral. Because I hadn't really thought about that. I'm not really into security as such, but that was one thing that I hadn't thought about before, and I thought that's brilliant. Could you put some words on what does it mean and why do you want it? And
so basically, the idea with having your like individual service workers, et cetera, but really any given VM container, whatever that's running in your ecosystem, be both immutable and ephemeral, is that this means that so immutability means that it means a number of things. One thing is that if an attacker gets onto that system, they can't change it, right? I can't reconfigure existing services to expose more vulnerabilities. I can't download attack tools and write them to disk. So in this case, immutable means no writable disk. And ideally no other writable config stores, anything, so that if you need to change anything in that container, you redeploy the container, right? So it's fully baked, it's never gonna change.
so what you're saying is that even if you get access, you can't change anything, you can't ruin anything.
Yeah, I can't change the image as it's running. I have to load stuff into memory on that process. And ideally you're running in a container and that only has the one executable in it. You don't have any other tools sitting around, et cetera. So I haven't given you, this is kind of another version of least privilege, right? If it's not code that's required to do the things that the container is supposed to be doing, it shouldn't be accessible to the attacker. So that's kind of additional code is a privilege in that context. That's a tool that I can go out and reach and pull in and that kind of thing.
Yeah.
So if I wanna do it, it's gotta be either already in the image or I've gotta download that code and patch the binary on the fly, that kind of thing. And you've made the attacker's job much, much more difficult, right? You've selected out, any attacker who isn't up for doing actual in-memory exploitation. And depending on the language and the environment, that's going to be more or less difficult. But so that's sort of one half of it, and then the other half of it is ephemeral. And this is so it depends what your startup cost for that container, et cetera, is. And ideally, in an ideal world, it would take 5 or 10 microseconds to spawn a new instance of a container, right? And so that kind of pushes us more towards the Lambda world, where every single function call is a new container lifetime. Yeah. And that's sort of ideal, because that means that, okay, so great, that call comes in and I compromise that container. Okay, well, there's a timer that's running now, and in 15 minutes, the timer for that function call max lifetime is going to expire, and then the container goes away. And if I want to retain, so if I'm doing reconnaissance, I have to exfil all my data immediately, and if I can't gather data, keep it around, and act locally on that data because I don't have a data persistence point because it's immutable, et cetera. And I also can't, I have to keep recompromising. And so compromises are generally relatively noisy. It's fairly rare that you're maybe you get lucky and you've actually just got a one packet in and you've got your code running. Great. That's pretty rare, right? Normally, if you're actually going to get a local compromise, it's going to be, okay, I've got a compromise, and maybe it's statistical, maybe it's 20 packets, maybe it's 50,000 packets. But then, okay, now I need to start injecting some tools, et cetera. And all of this adds a bunch of traffic noise that adds more logging noise. It makes them more likely to be detected. And so if in order to maintain persistence, you have to compromise a container a minute, right? Now you're generating a ton of noise. I'm probably just gonna start seeing that on traffic graphs. And I can be like, okay, wait, why is this one host sending so much, this doesn't
You're going to get
out.
suspicious.
Yeah, exactly. Or just, you're more likely to just notice it at all. You know,
because it's weird traffic.
It's weird traffic. It's not expected behavior. And so this is like that combination puts you in a place where it's much harder for an adversary to do anything if they get in, and it's much harder for them to stay in. Because that's the goal of the adversary, right? They don't want to just get an initial compromise. They want to, they have goals that they're trying to accomplish in the world, whether that's exfiltrating data, encrypting a bunch of stuff and demanding a ransom, all of these kinds of things. And all of those take time. If I need to go encrypt all of your databases and delete all of your backups, those commands take time to run. Like, the database has to physically read all the tables, and these aren't necessarily fast processes. So I need to stick around for a while.
Well, that's interesting. So you're actually using the physicality of the world, so to speak.
Yeah, exactly. I mean,
to protect yourself.
There's another idea that's kind of related to this I talk about, that's least capacity. So we're familiar with least privilege, where like you don't let people do things they don't need to do. But least capacity says that you don't. So let's say you have a database cluster that auto scales, and I find a nice convenient SQL injection, and you've got a lot of data and I want all of it. Great, your database cluster will literally auto scale to let me exfiltrate all of your data. Whereas if you say, okay, yes, it auto scales, but the auto scaler isn't based on database load, it's based on like, queries coming in the front end that are like invalidated application contexts, then I'm gonna start overloading that database, which is great because it's gonna fail and it's gonna annoy somebody, and somebody's gonna look at it and figure out, wait, why is this database overload? Well, let's look at the queries. I don't recognize that
Something
query.
Something weird is going on.
And so it's literally excess capacity in a system is also a form of privilege, because it's something that it allows the attacker to do a thing, but you don't need it for anything that the application is intended to do.
I like that, really.
And it's using the materiality of the system against them.
I was thinking, when you get that talk about ephemeral, I was thinking about, it's a bit like when you want to find a ripe avocado that hasn't gone bad yet. You have that small window.
Yes, it's about 13 seconds.
Yes, exactly. It's the same with avocados.
In Finland, where I live, it's about -3 days, where they almost always rot before they ripen. But that's a specifically Finnish problem.
But Finland in other ways.
Yeah.
Great. So I was thinking maybe you could tell us a very scary anecdote about security, so that people will need to listen to your talk to avoid getting in that situation.
So one of the things that we've found, I've been working in the security world for a long time, and this, I learned this lesson specifically doing training for NGOs and news organizations who are being targeted by nation states, is that when you scare people with a story, the brain stops forming long-term memories. And so until they get to a point where they're no longer scared, which is basically where they feel like they have agency in the world again, they don't actually process that much of what you're telling them, which, there are times, so I do fractional CSO work for a bunch of startups, and there are times when I have to explain the risk picture of a company to the board, to the rest of the C-suite, et cetera, that kind of thing, to let them know that, like, okay, we're gonna need to start spending some money, and I know that you don't want to, but here's why. And I try to be realistic in those, because we do need to talk about the actual risk structure, but I try to make sure that I'm not actually scaring them, that it's like, okay, so yes, here's the bad thing, and here's the agency that you have to stop the bad thing from happening. There are lots of terrifying stories and statistics out there. I don't know if the numbers have changed. The last time I looked it up, like the average time to detecting a compromise is 210 days.
Oof.
And most companies are told by someone else that, hey, you're sending us weird traffic, that kind of thing. There's plenty of bad news out there all over the place. And I think that one of the things that it's easy for, especially if you're running in a more traditional IT environment and you see just like these ransomware epidemic, et cetera, it's easy to get a bit fatalistic about it and be like, well, there isn't really anything I can do. And I mean, to a certain extent, that's true. Everybody gets owned eventually. However, that's not the end of the story. Because what happens after you get compromised is what determines whether or not this is a problem, right? How quickly can you recover? How quickly can you limit access? How quickly do you detect? All of these kinds of things. And there's a lot of stuff that you can do, both to make it harder to be compromised in the first place, but also to make sure that you can actually recover as a resilient team and actually, you know, get the attacker out, limit the damage, detect it, all of these kinds of things. And I think that it's, you know, both halves of that pie are important. And I think that that's the thing that it's worth telling people is that, like, yes, you're gonna get owned eventually. You're absolutely gonna get owned eventually. But it's not the end of the world, assuming you do the work now. Yeah. You know, and I will also say that, like, if you are a startup that's still in a seed round, there are some choices that you should make very, very early on that can lower your kind of overall risk. But a bunch of this stuff is not your problem yet. You need to actually make sure that you have a product with marketplace fit and all of that kind of stuff. Because I do meet founders who are in, like, very early stage. We are 2 developers, and one of them is staying up sleepless nights thinking about security. I'm like, no, this is not your job right now. Go build a company first. You know,
they end in an analysis paralysis about that. They don't get anything done.
It's like they're worried about it, but they don't have any actions to take. And, you know, this is where it's kind of my, you know, my recommendations, like, ditch your Windows boxes, ditch Office, you know, for the love of God, write in a type-safe language with automatic memory management. Don't write in C.
Help yourself.
Don't write in, as much as I hate to say it, don't write in Python, because type safety is your friend. You want enforced type safety, or at least use type hinting and all that. Anyway, but so there's some of these kinds of choices that you can make that when you get to the point where you now need to deal with the problem for real, you're going to be in a better place. The caveat of this, of course, is that you are still, even in a very small company, responsible for the risks that you put your users into, right? So if you're taking real user data, you know, if you're running in the world, you need to make sure that you're not overselling yourself and that you're not putting those actual users in risk. But it's this kind of flip-flop where user risk matters as soon as you have real users. Risk to the company actually matters much less then. Risk to the company only matters after there's a company to be worth putting at risk.
But in the beginning, worry about the users.
Worry about the users,
data.
Don't worry about anything else. And then later on, we'll go back and fix the problems. You know, because you're always gonna have some tech debt.
I think that's a good way to end this interview. Worry about the users. I think that's a very empathetic way to think about it. And thank you very much
for this has been fun.
Joining me in this interview. And I hope everybody will go online and watch your talk, because, as you said, everybody will get something out of it. I definitely do.
I certainly hope so.
Thank you.
Thank you.